In this tutorial, I would like to show you how you can use Location Visualizer in a professional context. I will start a bit with a history about the project to explain why the tool is used both by private individuals for location tracking, but also in professional contexts. I will also explain what typical contexts and use cases are and how you can provision Location Visualizer for more sophisticated deployments and applications, and how you can configure third-party clients and devices to integrate with it. Location Visualizer started out around 2018 or 2019 as a tool to visualize the data that Google captured as part of their timeline feature. However, soon I noticed that the data which Google provided isn't always accurate. Specifically, one would expect that if you take an export of your data at a particular point in time and then later took another export, that at least the raw location data that Google captured would just contain the additional data points that came in after the previous export. However, especially the entire timeline before the export should remain the same, since the past cannot change. In practice, though, that was not always the case. Though most of the raw data in fact remained the same, sometimes there were small discrepancies where a few past data points were dropped or a few new ones were inserted or some coordinates changed. Therefore, I introduced an internal location database to Location Visualizer, into which data from the cloud service could get merged, so that at least past data could be persisted in a way that it would no longer change after it was imported. However, Location Visualizer really gained traction among the quantified self movement as Google discontinued its cloud-based timeline feature in the beginning of 2025 and moved timeline to devices. People use the timeline feature to keep track of their whereabouts as part of a general quantified self movement, or use data collected to analyze commute times and distances for things like tax declarations and whatnot. And they were now in need of a replacement. Since Location Visualizer can import data from Google Takeout, it provided a natural migration path from Google's web-based timeline. People also use Location Visualizer to keep track of fitness or activity data like step counts, distances, energy expenditure, and so on. However, Location Visualizer ain't just a tool for private and personal fitness and location tracking. It's also used by small and large businesses and authorities for professional use cases. Potential key applications of the software that we're aware of are typical use cases of GIS software and include things like transportation companies visualizing relations within their network, keeping track of their vehicles, analyzing and optimizing routes, driving times, costs, etc., or mobile network operators visualizing the flow of mobile nodes between cellular towers. During the outbreak of the COVID-19 pandemic from December 2019 till May 2023, GIS software was used by public health authorities to visualize movement of individuals, either individuals who have given consent about their data being used as part of scientific studies, or anonymized data collected from network operators or through other means during the disease outbreak. Since Location Visualizer provides IoT and sensor integration, it's also used for environmental research. Researchers can track the migration patterns of wild animals by putting collars with integrated tracking devices onto them. You can have all sorts of environmental sensors monitoring things like air pressure, humidity, temperature, wind speeds, and direction deployed in the field, which also capture and transmit positional information. You can have sensors for asset tracking, surveillance of property like construction sites and equipment, etc. And you can use Location Visualizer as a hub for receiving sensor data. We also have quite some interaction with the OpenStreetMap project. On one hand, Location Visualizer can make use of OpenStreetMap data to provide the underlying map for visualization. On the other hand, OpenStreetMap contributors also use Location Visualizer to import, review, cleanse, and convert their location data that they captured during a survey and compare it to existing OpenStreetMap data to look for discrepancies and provide corrections. And of course, the developers of Location Visualizer also contribute to OpenStreetMap. So although the projects are not affiliated in any way, there is of course quite some interaction with the OpenStreetMap community. So in this tutorial, I would like to get a bit more into advanced configuration and features of Location Visualizer that you may use in a professional context. But of course, also many enthusiasts will likely use them also for private or personal use cases. This includes things like the official command line client, public key authentication, and device tokens for integration of IoT devices or third-party applications for submitting coordinates to a Location Visualizer instance. So to start out, I created a set of 9 files. 2 are in OpenGeoDB format, 2 are in CSV format, 2 are in GPX format, and 2 are in records.json format, and 1 is a shell script. And each file contains exactly 1 geographic position, each in a different city in Europe, and each with a different timestamp. And we still have the same user account that we set up during the last video, and we have updated Location Visualizer to the latest version. And what we will now do is we will create an RSA key pair using OpenSSL and assign the public key to our user account on the server. And then we will use the CLI client to upload coordinates from 4 cities using password-based authentication, then upload coordinates from 4 other cities using public key authentication. And finally, we will use the curl command to submit coordinate data using a device token. And then we will use the web interface to verify that all coordinates have been submitted as expected, and also that we can download the aggregate coordinate data again using the CLI client. And we will also discuss how you can configure a widespread mobile client for Android to submit coordinate data to an instance of Location Visualizer that's running on a publicly accessible server. And then in practice, if you have a set of sensors or other IoT devices deployed somewhere in the field, you can either install the CLI client on them and perhaps install an RSA private key on them and have them publish data to an instance of Location Visualizer. Or you can provision a device token for them and then have them publish their data without making use of the full challenge response-based authentication protocol. And of course, you can also have, for example, CI/CD processes running somewhere that can use the CLI client to download, process, for example, cleanse or merge, and upload coordinate data, especially using public key authentication. And of course, I will also show you how you can revoke access for a certain public key or a certain device token so that you can remove access for devices that have been decommissioned or compromised. So let's start out by generating an RSA key pair. If you have OpenSSL on your system, you can use the following commands. OpenSSL genRSA -out, and then you provide a path, keys/client-private.pem, and then the bit length 4096, and hit enter. This generates a 4096-bit RSA private key in the file keys/client-private.pem, and then the following command, OpenSSL RSA-in keys/client-private.pem, so the path to the private key, -pop-out, -out, and then keys/client-public.pm, so the path to the public key, or where you want the public key to be stored. This extracts the corresponding public key and stores it in the file keys/client-public.pm. You would then upload the public key to the server. Here we have everything on the same system, so we can just associate the public key with our username user. So we type /logvis add -public -key username, and then we have to put a description. We will have to put quotes around the description. So let's just put some description for the key. And then we have to provide the name of the file containing the public key, so keys/client-public.pm. And we can verify that the key is associated with the account by typing /logvis list -public -keys username. So we can see the index of the key, which is 0, the time in UTC when the key was added, then the type of the key, which is public key, since the key was in PKIX format. It would be RSA public key if the key were in the older PKCS1 format. Then we have some hash of the key in base64 encoding, and finally the description. We can also display the key in PEM format using the following command: /logvis show -public -key username 0. The 0, of course, is the index of the key, and we will see the entire public key in PEM format. Now let's also commission a device. These two features are independent. You can use public key authentication without commissioning a device, and you can also use device tokens without adding a public key. However, for our demonstration, we will make use of both. So let's just create a device token now. We type /logvis create -device -token username, and then we put again in quotes some description for the device. And what we see now as output on the command line is the device token that was actually issued for the device. We can also take a look at all device tokens associated with a particular user. We type /logvis list -device -tokens and then username. And now I can see we have some typo here. So let's just revoke the token and try again. /logvis remove -device -token username, and then I copy that device token here. And let's try this again. /logvis create -device -token username, some description for the device. And now we got a different token, of course, and now this was correct. Let's list this again. /logvis list -device -tokens username, and now we can see the token with the correct description. Now we will run the server /logvis, and we will create a second shell. So first, let's take a look at the data. City /data/cities ls. We have 9 files here, each containing coordinates of a different city. We can take a look at the individual files. Let's start with the 2 GDB files, hd amsterdam.gdb, hd oslo.gdb. And you can see the first 10 bytes are the preamble, which includes protocol and version information. Then we have 6 bytes for the timestamp. And then the second line in the hex dump contains the actual coordinate data, with the first 4 bytes being latitude and the second 4 bytes being longitude. Now, if the sensor were to send multiple data points in a single transaction, then we'd only have the 10-byte preamble once and then simply several 14-byte data points. So the protocol overhead goes down. Then we can take a look at the CSV files, cat berlin.csv, cat paris.csv, then the GPX files, cat london.gpx, cat rome.gpx, and the JSON files cat madrid.json, cat stockholm.json. And finally, we have a shell script here which submits coordinates in Vienna, cat vienna.sh. And now we will do the actual data imports. So let's first switch back to the location visualizer directory, cd // location visualizer. We do not only need the private key for our client, but also the public key of the server. This way we can verify that we're actually communicating with a legitimate server. So server and client do mutually authenticate each other. So we will also have to put the server's public key onto the client. So let's import our first data point. /logvis remote import -geodata, then the host name localhost, then the port 8443, then the public key of the server keys /public.pem, now the username, now the password secret, now the format the data is in that we want to import, so OpenGeoDB, then the import strategy, we will just use all, and then the path to the actual data, so we will use /data/cities/amsterdam.geodb. And this is the import report, so we can see that it actually imported one location, and we have a total of 1 locations now. Now let's change the format from OpenGeoDB to CSV, and let's import berlin.csv. Now we have 2 locations. So now format GPX and london.gpx, 3 locations. Now format JSON and madrid.json, 4 locations. And now let's change to public key authentication by adding the -pk suffix to the import -geodata command. Change the password secret to the file storing the RSA private key, which is keys/client -private.pem. Change the data format back to OpenGeoDB and import the file oslo.geodb. 5 locations. Next, change data format to CSV and import the file paris.csv. 6 locations. Change data format to GPX and import the file rome.gpx. 7 locations. Change data format to JSON and import the file stockholm.json. 8 locations. And now finally we will use the device token to submit 1 data point using curl. Curl -chi -d and in quotes CGI equals submit minus coordinates minus D, and then in quotes name equals username minus D, and in quotes device token equals, and we copy the device token from here, minus D, and then in quotes time equals 2025 minus 01 minus 09 TOO colon 00 colon 00 capital Z minus D, and then in quotes latitude equals 48.2083333 minus D, and then quotes longitude equals 16.3730556, and then the URL https://localhost:/8443/CGI minus bin/logvis. I made a typo here. Where it says time, must say time here. So this is what in a real-world scenario our IoT device would do after it has acquired a measurement. So now we have 9 locations stored. So we hit enter to get the shell back into a proper state, since the output of the curl command doesn't finish with a new line character. And then we will export the aggregate data, for example, in CSV format. /logvis remote export minus due data minus PK, so we're using public key authentication here, localhost 8443, and then path to the service public key/public.pem, then the username, and then the client's private key, so key/client-private.pem, then the output format, so CSV, and then the file where we want to store the export, so I would just say output.csv. And we can see that we get 9 data points. Cat output.csv. Great. So you can see this works as expected. And we can also take a look at the web interface. And see we have 9 data points here. Finally, let's get back to the first terminal session and terminate the server using Ctrl+C. And now we can remove the public key, /logvis, remove -public -key, username 0. And finally, we can also remove the device token, /logvis, remove -device -token, username, and then we copy the token from here. And we can verify that they're gone, /logvis, list -public -keys, username, nothing, /logvis, list -device -tokens, username, again, nothing. Let's clean things up a bit. Remove keys / client - private.pm. Remove keys / client - public.pm. Remove output.csv. And let's also delete the geodatabase since we started out with an empty one. Remove data / locations .geodb. Okay, finally I will show you how you can provision an application like Mentalk GPS Logger to submit coordinates to an instance of Location Visualizer. On this screen, which you will see on your mobile device, you can enable logging into a custom URL. Then you enable a few switches, put the API endpoint here, https:// then your host name. So here we have localhost. Of course, then if you want to log into an instance of Location Visualizer, which you have running on your server, you would put the host name on your server here, /cgibin/logvis. And then as HTTP text, you can configure the following. CGI equals submit minus coordinates, then an ampersand. Name equals username, or whatever your username is. Then an ampersand, then device token equals whatever your device token is. Then again, an ampersand, time equals percent, and then in capital letters time. Ampersand, latitude equals percent, and then in capital letters LAT. Ampersand, longitude equals percent, and then in capital letters LON. Then HTTP headers, content minus type, with the first letters of each word capitalized, colon, space, and then everything in lowercase, application /x minus www minus form minus URL encoded. Then HTTP method in capital letters post. And then it should work, but you will need a server that you can reach over the public network. So we did the demonstration now with command line utilities on Linux as a client, as well as with a mobile client on Android. Of course, you can use that with devices for wildlife tracking, vehicle trackers, IoT sensors, custom software you develop, as long as they have a way of accessing a network, establishing a TLS connection and sending data over that connection. And of course, your server running location visualizers reachable over the network, then they can send live data to that particular instance of Location Visualizer. And of course, you can also use the export facility for automated data analysis and stuff like that. So that's it. I hope you find that useful. As you know, Location Visualizer is a software that is under active development. What we're currently working on are support for live user management, which means creating and removing user accounts, changing credentials, adding and removing keys, provisioning and decommissioning devices, and so on without interrupting the service. Once we have that, we may also tackle things like multi-tenancy, support for multiple workspaces, etc. This is still in conceptual work, but it will also enable more complicated scenarios for professional users of the software. What would be useful for me as the maintainer would be more interaction with users of the software, more community building, spread the word, discuss on forums, tell your friends. I know that the software is used a lot and I can see what tendencies exist in the industry and also the open source community, and try to align my software with that and keep up with recent developments. But as the maintainer of the software, mainly you publish updates for the software, and you can see that it gets checked out quite a lot, but you only get some fragments of information about what it's even used for. So it's a bit of guesswork into which direction the development should go. The CLI client, for example, was implemented upon request by a user of the software who opened up an issue on GitHub. So, talk about it, publish about it. It also helps with visibility and ranking, but of course be careful that you don't spam the communities. So yeah, that's it from my side. Of course, you can also comment on these videos. Thank you very much and goodbye.